सब्सक्राइब कीजिए जेईई फिजिक्स को एंड बेल आइकन दबाइए लेटेस्ट वीडियो सबसे पहले देखने के लिए।
In my second video on YouTube, I have solved a problem which was an wire of resistance R is bent into a circle and a battery is connected at any 2 points on the circumference of the circle, which makes an angle theta at the center, and finding the equivalent resistance of the. Now few students commented that they can't understand few steps and someone telling that step is wrong. So I will clarify it at the end of the today's video. Before that, I continues my previous class, which was about unit, dimension and measurement. So I started the video the previous day, which was about the dimension. I calculated dimension of few physical quantities in terms of mass, length and time, and that was of mechanics. Today I will discuss the uses of dimension. So we have three uses of dimension. First one is homogeneity of dimension in an equation. So today's video is uses of dimension. Number one is homogeneity of dimension in an equation. Now what is meant by homogeneity? Homogeneity means equal in all directions. We know homogeneity of space, that space is equivalent in all directions. So homogeneity here, if we have an equation, there is a term plus second term equal to third term. So it is first term, it is second term and equal to it is third term. Principle of homogeneity states that the dimension of first term, dimension of second term and dimension of third term will be same. Here you have few sign, few mathematical sign such as plus, minus, equal, greater than, less than, etc. Physical quantities in the both sides of these signs will have same dimension. Suppose you are adding two quantity A and B and you get C. So as you are adding A and B, then A and B must have same dimension, because you cannot add time with mass, distance with time, distance with mass. You have to add mass and mass, time with time and distance with distance. So if A is represent a distance, then B also will represent a distance, and the addition of two distance will give a distance. So principle of homogeneity states this one, that when you are adding distances, then you will get distance. when you add time, you will get time. When you subtract distance, you will get distance. One thing, for an example, we have an equation of mechanics that if u is initial velocity of a particle and a is acceleration, then the displacement s in a time t is given by ut plus half a t square. Now, principle of homogeneity states that these three quantities, that is s, ut and at square, must have same dimension. Let's check it out. Here s is distance, so dimension of s is L. I have calculated it in my previous video. Now u, dimension of u is, as dimension of u is L t minus 1. It is velocity. And dimension of acceleration is L t minus 2. So dimension of ut becomes dimension of u into dimension of t. Dimension of u is L t minus 1. Dimension of t is t. So this becomes also L. So dimension of ut also L. Dimension of s is also L. So we have equal sign here and both sides have same dimension. Now dimension of at square. At square. Dimension of at square is equal to dimension of a into dimension of t square. Dimension of a is L t minus 2. All I have got in my previous video, you can watch it. I will give the link of the video in the description. Dimension of time square is t square. So L t minus 2 into t squared minus 2 0. So L t to the power 0. That means it is also have dimension L. So a t square also have dimension L. So we get that in the equation A is equal to ut plus half a t square, all quantities have same dimension. Now let we have another equation. One is write this equation that v equal to u plus a t square. Now is this equation dimensionally correct? Check it with the principle of homogeneity of dimension in an equation. Dimension of v is velocity, so L t minus 1. That is fine. Dimension of u also a velocity, it is initial velocity, so dimension is L t minus 1. It is also true. Dimension of a t square, as I get previously, it has dimension L. So this quantity have different dimension from this one. So this pair is correct. Equal sign here, both sides have same dimension. This pair is not equal, not correct. Plus sign here, but both sides have different dimension. So this equation is incorrect. This is not correct. So an equation, if dimensionally incorrect, then this equation will definitely incorrect. Dimensionally, if equation dimensionally incorrect, then that equation definitely incorrect. Now we let another example in which I show you that if a equation dimensionally correct, it may be incorrect. How? So take S is equal to UT plus AT square. From previous example, it has dimension of L. It is also have dimension of L, and AT square also has dimension of L. So the equation is dimensionally absolutely correct. But we must have a half here. But half is not given. So this equation is not correct. So this is a limitation of dimension. What kind of limitation? How the limitation is coming? Because the numbers 2, half, 3, all are dimensionless. So when dimensionless number come in equation, so they will not differ the dimension. So you write or not write the dimension, that constant. It will not alter the dimensional formula of the equation. So be careful about the use of dimension. This number will not come through dimensional analysis. You have to remember this number in the equation. You can check the form of the equation using dimension. So this was homogeneity of dimensional equation. The second use is conversion of unit. We can convert CGS to SI or SI to CGS using dimensional analysis. Let's take an example. The SI unit of force is Newton, and the CGS unit of force is dyne. We can find 1 Newton equal to what dyne, or 1 dyne equal to what amount of Newton using dimensional method. To find that, we first have to write the dimension of force. The dimension of force is, I told you to remember this one, mL t to the power minus 2. The dimension of force is mL t to the power minus 2. So unit, we have to write the unit in terms of base unit. Newton is not in terms of base unit. It don't give you the knowledge about the quantity. That the quantity depends on which it does not give. So we have to write 1 Newton has mass, that means 1 kilogram, into length, that means 1 meter, into time, that means 1 second to the power minus 2. That is 1 kg into 1 meter into 1 second to the power minus 2. And what one dyne? One dyne equal to should be 1 gram into 1 centimeter into 1 second to the power minus 2. Clear that I have written the unit as these quantities. Here I using the dimension m, kg, l, meter, t to the power minus 2, second to the power minus 2. Now we divide these two. So 1 Newton divided by 1 dyne is equal to 1 kg by 1 gram. 1 kg divided by 1 gram into 1 meter divided by 1 centimeter. 1 meter divided by 1 centimeter. And 1 second to the power minus 2 is divided by 1 second to the power minus 2. This becomes 1. It is equal to 1 kilogram is equal to 10 to the power 3 gram by 1 gram. 1 meter equal to 10 to the power 2 centimeter by 1 centimeter. So gram cancel here, 10 to the power 3, centimeter cancel, 10 to the power 2, we get 10 to the power 5. Thus 1 Newton by 1 dyne. 1 Newton by 1 dyne is equal to 10 to the power 5. That means 1 Newton is equal to 10 to the power 5 into 1 dyne. That means 10 to the power 5 times. So we get 1 Newton is equal to 10 to the power 5 dyne. Okay. So this is the second use of dimension. Application number 3, that is C, deducing relation among physical quantities. Among the physical quantities. So we get in mechanics many physical relations, such as the time period of a pendulum T is equal to 2 pi root on L by G. This is time period. A body is dropped and distance travel is equal to half G T square. These are the relationship between different physical quantities. Here we have relationship of H with G and T. Here we have relationship of time period with L and G. We can find that's dependency using dimensional analysis. So forget the relation first. Let I don't know the relationship of time with length of a pendulum and acceleration due to gravity. We know only that time period is depends on length of pendulum and acceleration due to gravity. So here we have a pendulum. The length of the pendulum is L, and here acceleration due to gravity is G. If you hold the pendulum here and release it, it will swing to that direction and reverse to the initial position again and again. So going to this extreme point and return back to the initial point the time is required is called time period of the pendulum, and this time period depends on length of the pendulum and acceleration due to gravity. Now, how is the dependency? If I use this experiment on the surface of moon, what will be the change in t? If I take the length of the pendulum half or double, what will be the change in t? It gives the question, the answer to the question will give the relation. We have to find the actual relation between L, G and time period t. So let us do it with the help of dimensional analysis. So as we don't know, let t is proportional to L to the power x, and it is also proportional to g to the power y. So t will be equal to some constant k, which has to be dimensionless, L to the power x and g to the power y. Here k has to be dimensionless, because if it will have also dimension, then t will also depends on it. But we previously know that t depends only on L and g, not any other physical quantity. So this will be a pure number. So we get t is equal to k L to the power x into g to the power y. Now write both side dimension. In the left side, the complete dimensional formula is m to the power 0, L to the power 0, t to the power 1. In the right side, the dimension of k is 1, it is dimensionless. Dimension of L is L, as it is length, and g is acceleration due to gravity, so it has dimension L, t to the power minus 2 and whole power y, this way. It is become L to the power x into L to the power y, t to the power minus 2y. Very simple. It is equal to L to the power x plus y, t to the power minus 2. And here in the left side we have m to the power 0, L to the power 0, t to the power 1. In right side we don't have mass, so we can omit mass from left side also. Now compare. Both sides must have same dimension according to principle of homogeneity of dimension in equation. Then here power of L is x plus y, and here it is 0. So x plus y is equal to 0. Here the power is t is 1, and here it is minus 2y. Therefore minus 2y should be equal to 1. So we have got two equations and we have two unknowns, and here I write that t is equal to k L to the power x, g to the power y. Now from here y is minus half. Put y minus half in this equation, we get x minus half is equal to 0. That means x equal to plus half. So here we get t is equal to k L to the power x, that means L to the power half, g to the power y, that means g to the power minus half. Therefore t equal to k into L to the power half by g to the power minus half, or t is equal to k, plus half, L by g whole to the power half. Therefore, T is equal to some constant K L by G under root. And the value of K, you know it is 2 pi, but it is limitation of dimensional method that in this method we cannot get the constant which is dimensionless. So this is the procedure to find the relation between physical quantities using dimensional method. If you are a class 11 student, then I suggest you dimensionally find the relation between some physical quantity. I give it here. Here I have a ball. This is spherical ball which has radius r. This ball is falling in a liquid. The liquid has viscosity eta. The viscosity of the liquid is eta. Viscosity means the very easily it is friction of liquid, and it has dimension m L inverse T inverse. It will help you. The resistive force on the ball F depends on eta, which is dimension m L minus 1 T minus 1, radius of the ball, and velocity of the ball through which it is falling. Now find the relationship between F, eta, R and V. Okay. So these one our third use of dimensional method. Now at the end of the class I will tell you the limitation of dimensional method. First limitation. Limitations. Few I have said earlier in the class. Now here another limitation is we have find the relationship between physical quantities using dimensional method, but it can derive you the relation between physical quantities which are in multiplicative format. T is equal to 2 pi root over L by G. It is multiplication and division form. No addition or subtraction there. But if there is addition or subtraction, then such as S equal to UT plus half AT square. It is addition of two terms. So if you write S is a function of U, A and T, and then find the dimensional method this equation, you will not get this equation. Try it and you will not get this equation because there is a additive term. So in case of additive term, dimensional method cannot be used. Secondly, I have told it previously that if there are some constant, then dimensional method cannot find you the value of the constant. So if you forget to write half and check it dimensionally, it will give correct. So a good concept is that dimensionally correct equation is not necessarily mathematically correct, but dimensionally incorrect equation must be mathematically incorrect. So if you get dimensionally incorrect, you can say that the equation is definitely incorrect. But if you get dimensionally correct, then you cannot say that the equation definitely correct, because there may be some mistake in the coefficient such as half, 2 pi, etc. And last one is that using dimensional analysis such as this one, we had two equations in x and y. One is x plus y equal to 0 and other one y is equal to minus half. These are two equations and two unknown that we can find it in dimensional method. But in mechanics we have three dimensions, m, l and t. So we can get at most three simultaneous equations to solve. But if I give you a physical quantity C which depends on A, B, D, E, F, you cannot find the relationship between these one using dimensional method, because you at most can take up to this. This will give three equation and you have three unknown MLT, you can find MLT power. But if you have five unknowns here, you cannot get the relationship using dimensional method. So these are all about dimension. Now I go to the problem. So some students commented that they cannot understand the procedure. So I tell you that they have problem. Here we had a wire of length L and resistance R. Now this wire is bent into a circle and a battery is connected across these 2 points, where these 2 points makes an angle theta at the center. As this is theta, so the outer angle is 2 pi minus theta. Now in the calculation what I have done, first I tell that a current will flow in this direction, it come to this point. Here it has two paths, one is this way, another is this way. This current will flow in this manner and come to here, and this current also come to here. So if this is I1 and this is I2, then I1 and I2 combined to form IA. So this part of the wire and the rest part are in parallel. So we have to find the equivalent resistance. Before I find the equivalent resistance, I have to first find the resistance of this and resistance of this. To get the resistance of two parts, I use the method that resistance of a wire is proportional to its length. So the whole wire has length L and resistance R. So it has resistance R by L per unit length. Now find the length of this one, find the length of this one, and multiply with this term, you will get R1, R2 separately. So how to find the length? If the radius of the circle is R, then from the definition of angle, theta is equal to arc length, that is L1 by radius, that is R. And 2 pi minus theta is equal to this arc length L2 by its radius. Both are same radius. So we get L1 equal to R theta and L2 equal to R into 2 pi minus theta. Now the question of one student, that in the second step I divide L1 by L2. Now he is asking that why I divide L1 by L2. First of all, we have the radius of the wire, radius of the circle in the equation. It has no use, so I have to omit this. And I have to find the length of L1 in terms of L, the whole length. Then I can multiply with this one, and L will cancel. To omit this R, we divide L1 by L2 and get theta by 2 pi minus theta. Now the question here, I divides in this manner, that L1 by L1 plus L2 is theta by theta plus 2 pi minus theta. One students have also problem here, that why, how can I write this? This is wrong, but this is not wrong. I show you. You will get this result. How? First reverse it. L2 by L1 is equal to 2 pi minus theta by theta. Now add 1 to both sides. Now add them. LCM L1, L2 plus L1. Here LCM is theta 2 pi minus theta plus theta. Now again take the reciprocal. L1 by L1 plus L2 is theta by 2 pi minus theta plus theta. Now L1 plus L2. L1 is L2 is equal to L. So we get L1 by L. That is why I divide L1 and L2 to get L. It is equal to theta by 2 pi. So therefore L1 is theta by 2 pi into L, and L2 is theta by 2 pi. Sorry. L2 is, L2 is L minus L1, that is L minus theta by 2 pi into L. It is equal to L into 2 pi minus theta by theta. So we get L1 is equal to theta by 2 pi into L, and L2 is equal to 2 pi minus theta by 2 pi into L. Now resistance per unit length L, resistance R, so resistance per unit length is R by L. Here we have length L1, therefore R1 is equal to L1 into theta by 2 pi, sorry, L1 into R by L equal to theta by 2 pi into R into L into R by L equal to theta by 2 pi into R, and R2 is equal to 2 pi minus theta by 2 pi into L into R by L. It is equal to 2 pi minus theta by 2 pi into R. So we get R1 and R2. Now the rest is given to this video, and I think we have no problem on the rest. So this is the answer. So students, this is the end of today's video. I have started yesterday the classes of 11, and which we also for NEET JEE. I first started dimensional method. So these two lectures on dimension of physical quantity. In tomorrow's lecture, I will solve few exercise from very famous book of India, Concept of Physics by Professor H.C. Verma. So this is the end of today. Thank you.